Okay, so hello, welcome to week 3. Today we're going to be expanding a little bit more on what we've been learning. We're going to be doing some more sketching stuff, but we're also going to be doing something entirely new, which is assemblies. So, canvases and assemblies is what we're focusing on today. So, for assignment 7, we have this engineering fountain, which I'm sure you're all familiar with. We're basically going to be kind of reverse engineering this today, at least like on a scaled factor. So a lot of the times you might encounter a time when you might be designing something around something that already exists, or you want to design something based off something that already exists in your lab. And what you could do, you could go to the engineering fountain and like measure everything. That would probably take quite a long time. But the other thing you can do is you can take a reference photo and use that and import it into your CAD. So what we're going to be using is this reference photo from the engineering fountain to kind of reverse engineer it. Obviously, this is like not going to be exact, but it'll get us pretty close. So this is useful not for just modeling like big structures like a fountain, but for also small things. Like some people would like take a photo of something that's quite small with their phone. They might put like a coin next to it to kind of get a reference of the size, and they can design around it. So, maybe you're making a tool holder that like fits a tool and you want it to fit perfectly around your tool. You can like take a photo of it, import it into Fusion, and then design stuff around it. So that's kind of what we're going to go after with this today. Today we're doing engineering fountain, but you can do it for pretty much anything. So to do that, basically, we have to obviously insert the image into our CAD. So they call that a canvas in Fusion, and I'm just going to jump right into it. I should have uploaded this fountain into the Discord, so you can download it and then import it into Fusion. So let's see. To do that, I'm gonna close this. You just insert a canvas over here on the far right corner. It's a big image icon. It also kind of gave you a preview of what it does. Another use case that a lot of people use for canvases is they might draw something for reference. So you can see someone drew a car and then they use that canvas as a reference to model it. So a lot of people will like take pictures of their car from like the front, side, top, and rear and stuff like that. And then they'll model their whole car using those photos. But you just want to insert the image. Into here, and then you select a plane. It doesn't really matter which one you select. I'm just going to select this one here. But you can see here, we now have this canvas of the engineering fountain here. You can see there's a bunch of different parameters that you can change if you want to resize it. I'm just going to leave it as is today, but you can adjust that if you ever find the need to do so. You can also change the canvas opacity, which is basically how see-through it is. I usually leave it at 50%, but you can kind of change it to be however you like. But I'm just gonna confirm it, press OK, and then now we have our engineering content, right? What's up? I mean, you can just zoom in, but you should be able to adjust the scale with like these numbers here. I think if you change it, then it gets bigger or smaller. So yeah. Does that make sense? Okay, cool. Okay, so basically what we're gonna do, we're gonna kind of take some concepts that we've already learned, like kind of like the pattern tool and the mirror stuff, but we're going to apply it to bodies instead of sketches. So last week, we circular pattern like parts of sketches to create that gear. What we're going to do is we're going to do the same thing, but with features or solid bodies, right? So basically, I'm going to just sketch one side of the engineering fountain, and then I'm going to pattern it. Obviously, this photo isn't perfectly centered, but that's okay. I'm just going to be using this left one as a reference, and then I'm going to be patterning it in a bit. So I'm going to create a sketch. It's going to be on the same plane that we kind of made earlier, and then I'm going to just start tracing. For this assignment, don't worry too much if it's not fully constrained. This is just kind of more conceptual, so don't worry if your lines aren't all black and stuff like that. Okay, so what I'm going to do is I'm going to just start drawing some lines. I'm going to make these like horizontal and vertical lines. Thank you, Harry. And again, this is just an estimation, so don't freak out if it's not perfect. So I made some rough lines. You can also hide your canvas if you ever have the need to maybe see your lines better. But I'm going to make this curve now. A fun fact about the engineering fountain, this curve is actually not just a normal like circle or arc. It's actually modeled after the e to the x function. So you can't recreate this with a normal arc. So you have to create it with a spline. So similar to that wire that we did last week, we're going to be using the fit point spline. And then we're going to be making, a curved profile. Again, it's not completely exact, but it'll be pretty close. So I'm going to click my way down with the fit point spline tool. You can see how the curve will slowly start to represent itself. One tip I have for this assignment is I like to make sure when I'm clicking my way down that I make a couple points at the edges here, because I like to make one big spline and then trim it away, but you're welcome to make two separate ones. So I'm going to click my way down to here. And then when you're finished with the spline, you just hit the check mark. You should be pretty good. Okay. So you can see here we have this profile. It's slowly coming in. Then I'm going to add these vertical lines here. So just two vertical lines. And then I'm going to trim away. So I'm going to get rid of this line and then this one. And then now I have two nice separate bodies here. They're nice and closed because the inside is highlighted blue. So this looks good. Also, if you're wondering what all these green lines are for, it's just kind of how Fusion represents the splines. If you like manipulate these and stuff, it'll like change how the spline looks. So I'm just gonna leave it as is, but if you're wondering what those green lines are, that's what it's for. Don't worry if it's like overlapping your sketches and stuff because you can't trim it. But yeah, this looks good. I'm gonna extrude this. Similar to last week, I'm purposely gonna do something quote unquote incorrectly, so I can fix it later and you can see the difference it makes. So I'm gonna start with a one-sided extrusion, but it would probably be better if you made a symmetric extrusion in this case. But I'm gonna leave it one-sided for now, and then I'm gonna adjust it later. So extrude by some amount. 4 looks good to me, and boom. So we have that engineering fountain, or at least a quarter of it. That looks good. Okay, raise your hand if you're not here yet. Okay, I can wait like a little bit. Okay. So now that we're here, I'm gonna pattern it. So similar to last week with the gear thing, you're gonna go under create and pattern, and then we're gonna do the circular pattern just like before. But in this case, you can see here, there's a couple more options, right? In this case, we're gonna select some bodies that we want to pattern. So I'm gonna go with bodies, but you can also select, features and stuff like that, which is pretty cool. So I'm gonna select these two bodies. I'm gonna specify an axis. In this case, it's the y-axis, this green line. And then, obviously, in this case, the quantity is 4. And when I confirm it, you can see we've created 4 patterns, but something seems a little off, right? You can see that, typically for, our engineering fountain, everything is nice and aligned, but all of these have a slight offset, right? And it's because of the way we created the extrusion, because we created it on the right plane here, and we extruded it in one direction. The extrusion is technically asymmetric from your axis of like pattern, if that makes sense. So to fix that, we have to make sure our extrusion is symmetrical. So in this case, I'm going to go back and edit the extrusion. And then I'm going to change it from direction, or the direction from one side to symmetric. And then distance should be half of it. And when I do that, you can see the pattern looks a lot more correct, right? So keep that in mind when you're patterning stuff, because sometimes you'll pattern things and they look weird and you're like, why did that happen? It might be because you have an asymmetric extrusion. So yeah. All right. Raise your hand if you need more time. Okay. So now that we have this, we're going to start adding some more detail to this fountain. You can see here, like in the image, there's like, I mean, you've all probably seen the engineering fountain, but there's some like texturing on the underside. So what we're going to do is we're going to cut out those textures. It doesn't have to be exact again. It's just an estimation. What I'm going to do is I'm going to, again, do things out of order on purpose just to show you that you can do it and change it later. But when you do things out of order, you have to be very mindful to not create dependencies. So we were talking about the dependencies for like the shell last week. The same thing applies for stuff like this. So I'm going to create all the details on one of the bodies, and then I'm going to move the pattern in the timeline. But to do that, I need to be sure that I'm working on the correct body. So I'm going to confirm by clicking on the extrusion to show you, this blue one was the original one that we patterned. So if we edit this blue one and then move the pattern, then all the other patterned ones should change with it. But if we edited one of the pattern ones and then tried to move the pattern, that wouldn't work because, one of them is dependent on the other. So to eliminate that, I'm going to make sure I edit the original one, which in this case is highlighted in blue. So I'm going to create a sketch and then I'm going to project these surfaces. So pressing P opens the project menu. I'm going to click on these two faces, press OK. I'm going to hide the bodies just so it's a little bit easier to see. But you see when I projected it, these lines are purple, showing that they're referencing something that already exists. And then we're going to build off of this. So I'm going to create this detail. I'm going to be just using some splines. So, I'm going to just click my way down to maybe like here, and then make another spline over here. So you can see using those projected lines, I just created those two splines, and then now I have these nice closed bodies or closed areas that I can use to extrude. Yeah, okay, I can do it again. Okay, so making a sketch, I'm gonna do it on the face of the original body, and then to project, I just press P, which is the hotkey for it, and then I click on the two faces that I want to project onto the sketch, and then I press OK. And then I just, for visual sake, I just hide the bodies just so it's easier to see, but you can sketch with or without them. But yeah, I'm gonna make those splines again, just again not super precise, just working my way down, and then doing this side. And then, you have these two closed bodies. Okay. Do you want me to do that again, or is this good? Okay, sweet. So I'm satisfied with this. I'm going to finish the sketch, and then I'm going to extruded cut these sketches. So to make these details, I'm going to make an extrusion. I'm going to click on the two closed bodies that we created, and then I'm going to cut it into the model. So you can see the blue arrow is kind of going outwards. So to cut it into the model, I have to set the value to negative. So I'll do like -1. That looks good to me. And then just to confirm, I'm clicking the original extrusion in the timeline. You can see here that the only one edited was the original one. Who needs more time? Okay, no problem. If you're having trouble with the cut, and your body's like not visible, Fusion will just like ignore it. So you need to make sure your body's like unhidden, or else it'll just kind of make it back. Yeah, I'm trying to, honestly, okay, so now that we have this one side, we obviously want to have it be the same on the other side. There's a couple of different ways you could go about doing it, right? There's technically no wrong way. You could make another sketch on the other side, project the original sketch that we just made and cut it. We can use the original sketch that we did and cut it with a reference to the other side, or we can mirror it, right? Um, every way of doing it has its own advantages and disadvantages. If you created like another sketch on the other side, that might mean you might want to make those sides different from each other, right? Or make it open to be different from each other in the future. But if you just mirrored it, then you're ensuring that it's always going to be the same all the time. Right? In this case, I want to mirror it, but whichever way you choose will be dependent on what you're designing and what kind of flexibility that you're looking for later. For me, like the mirroring is very convenient. If one side changes, the other side will change with it. But if you don't want that, depending on what you're going after, that's okay too. So I'm going to create a mirror instead of in a sketch. I'm going to be mirroring a feature. So you can see here, I can mirror a body, but I can also mirror a feature. So I'm going to choose a feature. In this case, it's this extruded cut here. It's going to ask for a plane at which I want to mirror it. So I'm going to mirror it across this plane here. And because the extrusion was symmetrical, because we're mirroring across this original plane, it'll be in the same spot on the other side. So that's another reason why sometimes symmetric extrusions are nice. It'll help with mirroring later. Compute type, I think adjust is usually fine, but sometimes you might need to mess with it being like identical or something like that. Adjust is usually fine though. Yeah, in this case it did it right. So You can see here, wow, I'm lagging a lot. You know, both sides are symmetrical. This looks good to me. So we have this original body looks good. The other ones, not so much. They, you know, they're unchanged. It's because the order at which we made all of these deemed it so. But again, you can adjust your timeline accordingly if you ever need to make changes like this. So, you know, I can just drag this pattern to be in front of all the stuff we just did, and then it applies it to all of these. So that's kind of what we're going after. You know, normally if I was modeling this, I probably just would have done it in this way to begin with, but you know, making sure your CAD is easily changeable might be a good idea if you ever want to do that in the future. But yeah. I think the last detail on this is just adding a base to the engineering fountain, and then we can call this assignment done. Or you can lag on me instead. Okay, so we're making this base. So new sketch. In this case, I'm selecting this bottom face. I'm going to make 2 circles. And then I'm going to extrude it. So this looks good. I'm going to extrude it. I think sometimes it asks, or it will want you to select like this face for some reason. I think it's because we created the sketch on this face, and then it just assumes that you may not want to extrude it, but in this case we do. Add some thickness, and boom, and finished. Does anyone want me to go over this again? Okay. Any other questions for this? Any other questions about this assignment? Okay. Oh, we're going pretty fast today. All right, final call for the engineering. What? Yeah, this is it. So this is finished if you're at this point. Okay. So now that you know how to create sketches and extrudes and bodies to create your parts, typically you might want to join certain parts together. Right? A lot of things that you want to design aren't just a single part. Um, you might want a group of parts together, test fitting them to make sure it all works nicely. Um, and Fusion and a bunch of other CAD softwares have ways of putting parts in together, in relation to each other, right? And they're called assemblies. So what we can do is we can assemble these parts into, a digital model to make sure everything works well. And it's really nice to, catch errors and also just see what your model is going to look like before you might make it. So today we're going to be doing this Lego car, and then we're going to be using joints and constraints to make sure this is all nice and solid. In the past, we've only used the joint tool, but Fusion just recently came out with a constraint function that I honestly like a lot. So I'm going to be teaching both tools. But in general, I think the constraint tool is better. But in the past, we've only done joints. But it's mainly just because the constraint tool is new. So yeah, I think it came out like within the past like month or two. So it's pretty cool. At least I've only noticed it in the past month or two. Maybe it was like hidden somewhere. But anyways, you just want to download this zip file and then extract it. So yeah, it's totally a virus. It's definitely a zip bomb. Yeah, for the record, it's not a zip bomb, so don't worry. I have to say that because it's recorded. But you just extract the file and then import it into Fusion. I've already extracted it, so I'm not going to do it again. But I'm going to open the data panel. For organization's sake, I usually just put all of these parts in a new folder. So I'm going to make a new folder here. And then I'm going to upload models. Just copy everything. Oh, oops. Did I have an engineering fountain step file in there? I may have sent you guys an engineering fountain on accident. Okay, ignore this. Okay. Yeah, I think I accidentally put the engineering fountain, a step file of it, in this folder. So I really hope no one submits this. But if they do, I will know because the timeline's wrong. So yeah, don't submit this for your homework. But if you do, I will know. Anyways, you can see now that we've uploaded all the files, you can kind of see all the previews, all the parts we have. But now we can start putting them together in an assembly. So to do that, we're going to create a new document. And the first thing I'm going to do is I'm going to save this file. So you can't create or you can't insert parts into an assembly if it's not saved. So I'm going to just save this blank document as the assembly. And then I'm going to start importing parts. So for me, I think it's best practice to insert the part that you think is like the base of like your general assembly. Like for example, like this car, I wouldn't imagine you like would call the wheel of the car like the base of it, right? Because the wheel is attached to a frame. So I think it's better to use the frame as a foundation for our assembly. So in this case, there's a 2x6 like plate that spans the whole car, and I'm gonna kind of treat that as the foundation of our assembly. So right here, this 2x6 plate, you can drag and drop, or you can right click and then do insert into current design. It'll give you a nice preview. There's no parts right now, so it's just kind of in space, but this looks good to me. I'm gonna press OK. You can see here in the top left, there's a little anchor next to like the body of this part, and it's because it's grounded, right? And when it's grounded, it means it can't move, and it's locked in place. So it basically is kind of like a fixed constraint. But because these parts don't have any spatial like awareness, you have to place them somewhere. And having a fixed area or one fixed like part kind of makes it so all the other parts don't fly around randomly. So it's kind of like making your own origin here. So that's why this part is grounded. You can unground it, but you really shouldn't. But yeah. So now that we have that, we can start inserting new components. In this case, I'm going to start with the axles. And I'm going to show you both like the joint and constraint method. Personally, I like the constraint method better. It'd be nice if my Fusion didn't freeze. All right, come on. There we go. Okay, so I'm dragging this other part here. I think it's, or a tip I have for most people making assemblies is that you don't want to place the part exactly where it's going to be, because when you create your constraints in assemblies or constraints in joints, it's really nice to kind of visualize and confirm that it's actually going in the right place because you're telling it to go there. Similar to like when you're creating sketches, and I sometimes make the sketches purposely look off and then I add geometric constraints later. This is the same concept. So I typically move stuff a little bit far from where they're going to be when I place the part. So this looks good. I'm going to confirm it. And I'll teach the joint method first. So this is what we've done in the past. Fusion has a tool called the joint tool, and it's useful for creating relations between two different parts. So what you do here for this case is I usually like the two-edge intersection tool for more square parts, because then I can specify two different edges that correspond with each other. So I'll do this for both of them, and then I start my selection. So you can see here there's edge 1 and edge 2 for both components. You want to make sure that the edges you're selecting correspond with each other. So in this case, like this Lego piece, like this bottom edge should align with this one here, and then this like horizontal edge should align with this one. So I'm going to first start with this top piece. I'm going to select these two edges, and then I'm going to select the corresponding edges, and then the piece is going to fly into place. This is fitting. Okay, so normally I think it defaults to rigid, but I had Fusion open and I was doing other stuff. But with the joint tool, you can specify different kinds of relations, right? So it's nice to, these parts shouldn't be moving from each other, so it's rigid. But if you wanted things to spin and stuff like that, you can set these to revolute, or like have things slide with the slider. I think it's pretty useful, but the one downside of the tool, in my opinion, is that it's primarily edge-based. And when I say edge-based, when we went to select, parts on the components, we selected like these edges of the parts, right? And when you're designing things, your edges will change a lot, especially when it's not finished. Like you might make your assembly file before you finish your design. And then what I normally do is like near the end of the design part, I'll start making the part look pretty, and I start adding like chamfers and fillets on a lot of edges. And if you do that, it'll break the joint tool in Fusion because you're gonna essentially delete the edges that is referencing, right? don't like about this tool. It can be very convenient when you're applying like motion stuff, because you only need to have it specify a couple places for you to get the motion you're after. Um, but with the new constraint tool, which I'm going to show in a little bit, I find it to be a little bit more precise. The constraint tool is also very similar to a lot of other programs that have assemblies, specifically like SolidWorks and I think NX and I believe Inventor have a very similar assembly function to the constraint tool. So that's why even though it's new, I think it's a really good one, and I'll teach it in a second. But yeah, that's how you do the joint tool. One thing I did discover recently, like through my testing, is there's a bunch of more like advanced features, like using like intermeshing like gears, or when you're setting like gears to intermesh with each other, you need to use the joint tool to create those relations. So keep that in mind. I'm not really going to be going over that today because that's a little bit more advanced, but if you want to create stuff like belts and pulleys and gears that mesh with each other in the assembly, then keep in mind that you might have to use the joint tool instead of the constraint function. Yeah. I'm going to set that as good. And then I'm going to insert the other axle. I'm going to move it in its general area. And then instead of the joint tool, I'm going to use the constraint function. So oh yeah, it's from a part standpoint, it's the exact same part. Yeah. So what I like about the constraint function is that you can specify edges over, I mean not edges, you can specify faces over edges, right? So again, like I was saying, if you use an edge to constrain something and then you add a fillet later, it's going to break it. So it's a good idea to use a face instead of an edge. So what I'm going to do is I'm going to select 3 sets of 2 faces to fully constrain this model. So because it's a Lego piece, I know these 2 circles should be concentric with each other, along with these 2. Well, all of them wow, should be concentric with each other, but you only have to select 2. So I'm going to select this one and this one. You can see it creates this constraint. And then you can add more constraints in one constraint like group basically. So there's this plus function. I'm going to add a constraint. It's going to ask me to specify one face and then specify another face. So when I select these 2, I'm going to confirm it. I selected those 2 faces to be constrained to each other. So now, like, you know, because these 2 are constrained all the time, you know, this is not going to move in the kind of XY direction. I didn't finish the Z, so I'm going to edit this. And then for the last one, I'm going to add a constraint. I want the bottom of this piece to be touching the top of this piece. So when I do that and I press OK, it's in the perfect spot. So it is a little bit more work compared to the joint tool, but when you get into more complicated assemblies, I find that being able to specify these constraints individually tends to be a little bit more precise and easy. And again, there's that whole like edge versus face thing. So yeah. This is actually a great example of how the constraint tool makes things a little bit easier. A lot of students had trouble with adding the middle piece in between the axles, or in between these axle pieces, because the length of these Lego pieces isn't exactly, like this 2x2 isn't exactly like 1/3 the length of the 6x6. there's a slight like tolerance in between all the parts. So if you have like the two faces up against each other, you're gonna encounter a small gap, right? But in this case, the gap is intentional. But I think using the constraint tool is gonna be a little bit easier for this part versus joints. So I can basically do the same thing I did here, but with this part, I'm gonna constrain these two cylinders with these two, and then I'm gonna constrain the face. So constraining here and there, and then there and there, and then here and there. So this looks good. Let me see if I can zoom in. Yeah, okay. So you can see here, like in this Lego model, like these cylinders should be like concentric with each other. So this is placed correctly, but you can see there's this really tiny gap here. And like, you know, it's kind of hard to know what that gap is unless you design these parts, which we didn't. So if you were to use the joint tool and then constrain it edge to edge, this gap isn't going to exist unless you create an offset, but you know, that offset is unknown. So that's why, you know, in cases like this, I think the constraint tool kind of comes out on top. Does that make sense? Yes? No? Okay. Sure. Yeah, I'll do it again. I'm going to use this piece here on the back. I'm going to just move it. Again, it's not in the exact spot I want it to be. I'm going to even move it farther away so this makes sense. So I'm going to add some constraints. In this case, I want this face and this face. Wait, actually, no, I'll do the circles again. I want this one and this one to be constrained to these two. So I'm going to constrain this cylinder to this one. And then I'm going to select the plus. I'm going to select this and that one. And then finally, I'm going to select the bottom and the top. Okay, raise your hand if you want me to do that again. Okay. So I'm going to do this front piece here. I'm going to reposition this just kind of over here. And in this case, you can see like I can't do the two cylinder thing because there's only one on top. So I'm going to be using all these faces instead. So I'm going to create a new constraint group. I'm going to click on one face, which is this outer one. I want it to correspond to this one here. So now it's there. then I want these two faces to be on the same plane. So I'm going to add a constraint. I'm going to select this face and the corresponding face here. And then I want, this part is phasing through it right now, but I want the bottom of this piece to correspond with the top of the long plate. So I'm going to add another one. I'm going to select the bottom face of that piece and then the top face of that long base plate. Yeah, I'll walk around the room for a little bit. You got plenty of time because this is basically it. Oh, I was trying to move it to make it a little bit easier. It like makes everything. My one gripe about this is that yeah, I think so. Now that you're hopefully getting this down, something that I haven't mentioned yet is that you can add assemblies in assemblies. So, for example, we have our car here, but most cars, if not, well, not all of them, but almost all cars have 4 wheels and tires, right? So, we could add each wheel and each tire individually, or we can add both of them at the same time with a subassembly. So, to save a little bit of work, what I'm going to do is I'm going to create a subassembly. So, I'm going to save this. I'm going to create a new design. I'm going to save this as its own assembly. wheel and tire assembly. And then I'm going to insert the wheel and the tire. I'm going to constrain it, and then I can insert it into the main assembly. This looks good. Okay, so I have my wheel and tire. I'm going to constrain it there and there. Perfect. Okay, cool. So I created this constraint, right? It's concentric with each other. I want this tire to be centered on this wheel, right? So it's kind of hard to tell or kind of hard to see. But the wheel is ever so slightly wider than this tire here. So if I like constrained there to there and the offset was 0, then technically, you know, there's going to be a little bit of a gap, but we want that gap to be on both sides. In my case, what I think I'm going to do is I'm going to add a constraint, but instead of to the faces or whatever pieces on these parts, I'm going to constrain to planes in the design files. So you can create constraints from these faces, but also on planes inside your parts. So I'm going to edit this. I'm going to add a constraint. And then instead of selecting these faces, I'm going to go and open some of these origins. So you can see here, I've opened the origin inside the buggy wheel file, and then I can select it to constrain to it. And then I can do the same thing on this wheel. So I'm going to hide this. Or I can do it to the tire. So I unhid the origin on the tire, and then I selected, or I'm going to select this plane here. And then when I do that, you can see with that constraint, there's a tiny little gap on both sides. And it's because these two are separate. So you can do that if you want. Like I'm genuinely not going to notice if you just do face to face. But I just wanted to show that to you to show that you can constrain things to planes, either in your assembly file or like opening the planes in your parts. So that can be useful. Another thing to note, another like reason why you might want to do a symmetric extrusion is it creates or it leaves those planes that are given to you like centered on the part, right? So, for the person who designed this, right, they could have extruded this in one direction, but then instead of doing that, they made the extrusion symmetrical. So it leaves the origin kind of in the middle of the part. So it can be useful for assemblies too, not just your normal part files. So again, that's a really like niche or like small like difference in how you might design things. But it can really make things a lot easier for you in the future, depending on what you're going after. Does that make sense? It's like a very like technical, like nitpicky thing that I'm talking about right now. So it's okay if it's like, if it sounds kind of dumb. But yeah, anyways, this assembly looks good. I'm going to save this. And then I'm going to insert the new assembly we made into the main assembly. So down here, you see there's the wheel and tire subassembly. I can insert it into here and then constrain it. So constrain there and here. And there. And there. Okay. Yeah. What's up? Like this. Yeah. So you first need to make this subassembly, right? And then make sure you save it because the initial save is a blank document. And then you can go back into here and then just drag it in just like any other part. But make sure you save it. I've had people try to insert the wheel, but because it's not updated, they're just inserting nothing. And then they're like, why isn't it appearing? Yeah, like the plan stuff. Yeah, I'll do it again. Okay, insert. Okay, so I have these two pieces, right? If I open these drop downs here, you can see like more information about the parts. Typically, if you model these in Fusion, you can see all the extrusions and features and stuff like that. But because it's a step file, you can only see the body. So you can see the body, but you can also see the origin. So if I unhide these, it opens up the planes, like the origin planes from the original file. And you can see, at least visually, these planes look like they're centered on the whole part, right? So I'm just kind of assuming in this case that like this face and this face is like an equal distance from the center here, just because it makes sense. It's like a symmetrical extrusion. But we can use these planes to constrain this wheel to the tire, because I can be like, I want this plane to like be on the same plane as this, right? And because they're both symmetric, or because these wheels and tires are symmetric on the planes, it'll center the tire to the wheel. So I'll do that first, actually. So if I constrain it, or if I add a constraint and I select this face and this face, you can see how it's now centered on the same plane. And then I can add one more constraint to make sure, oops, to make sure these are concentric with each other, like that. Does that make sense? I can do it again if it's, you want me to do it again? Okay, yeah. Okay, so again, there are these drop downs for each thing you insert into your assembly. In this case, I really want to access this origin here. to see all these planes. Because these planes are centered on these parts, I can use them to constrain the tires. So I'm going to add a constraint. I'm going to select this face here, which is in the middle of this part. And then I'm going to select the corresponding plane, which is this one here. So I'm going to click this one and this one. So that constrains that like to be centered. And then the second one I'm adding is just to make sure they're concentric. So this face and this face should be concentric. And then when I press OK, it's nice and centered. I don't either.
That's a mentally aware.
Yeah, very, very good, very good. Actually. Okay. The only thing to note about this assignment is that you need to make sure you add appearances. So you'll lose points if this thing's not colored. Again, please make sure it's not like gray, because if it's gray, I'm just gonna assume you didn't do it. So yeah, if it's nice and colorful, it'll make my life easier. But yeah, that's basically all for that assignment. Your homework assignment is basically more of this, but it's free range. You can make whatever you want. In this case, like in this photo, there's a car. You don't need to make a car. You can make anything you like. Yeah. Okay, I'll fix that later. But yeah, you want to use the joint tool or the constraint tool to make your own Lego set. Obviously, I'm not going to ask you to model your own Lego. So you can use like the parts that we have for this assignment, or you can find your own Lego bricks online. So one of the great things about CAD is that a lot of people post their files online, and you can use these files for your own designs as well. So In this case, we can look for Lego stuff, but I'm going to show you a couple different resources now that might help you in the future when you're designing other things other than Lego. Um, so I'll first start looking for Lego. One place that I like to go to is this website called GrabCAD. They used to have like a program that I used to use in high school, and it was really nice for SolidWorks, but they killed it, and now I'm sad. But their library is really nice. So if you go to the GrabCAD library, if it loads, um, it's basically an online repository where people, you know, upload their designs, um, and you can download stuff. So some of the stuff gets pretty crazy. I've seen some pretty wild stuff on here. Um, oh, okay, lots of guns. Okay. But you can see here, like people upload all these models for free, and you can kind of download them. Like, maybe you're building a PC case and you don't have a CAD model of your graphics card. You can just download it here, and then use that as a reference. But you can also, find stuff that you might be looking for, like Lego. So, well, GrabCAD website's really slow today. But you can see here, people have uploaded a bunch of Lego stuff. Please don't just like submit this because I'll kind of know, because again, I'll see your timeline. So if you just, yeah, I mean, you did the Empire State Building, so I think you downloaded these, but like, yeah, no, that's fine. So just like, if you get like a complete model and you just send me a screenshot of the model, I'm gonna know. So just like make sure you have your joints and your timeline in the photo so I, know that you actually did it. People have like sent me really weird things. I'm like, okay, your timeline doesn't look right because I don't see any joints or constraints in there. So yeah, please make sure your timeline's there so I know what you're doing. But yeah, there's a bunch of models here, individual bricks. I think there's a link. I have a link saved somewhere. I need to find it where you can download a bunch of bricks and stuff like that. So I'll send that later. But repositories like this are very useful, not just for Legos, but for finding more standard components. For example, a lot of people like to design stuff around, bearings and specifically skateboard bearings because they're very common. So we can look up a skateboard bearing. I think the official like name for a skateboard bearing is a 608 bearing. So if I look that up, you can see here a bunch of people have modeled them, and then you can download them and insert them into your assemblies, right? It usually saves you a lot of time because you don't want to model a bearing, because you can just download it. So feel free to do that for your designs. The other thing, or another website that I find really useful, is a website called McMaster-Carr. If you're familiar with it, it's basically like a super big online hardware store. So you can buy everything from like bolts and washers to also like really random things. Like you can buy ketchup and like Swedish fish and like stop signs. But anyways, um, they have a really wide selection of hardware. So you can go and find the thing that you really want, like, this random bolt here. They'll give you a part number, but if you click on it, there's an option for you to download the CAD. So you can download like the step file, and then when you do so, you can upload it into your Fusion folder and then utilize that hardware, right? So this is really great for a bunch of like standard components like bolts and bearings and stuff like that, because no one wants to spend their time just modeling something that already exists. So yeah, it uploads. Yeah, what's up? I think you can mirror it, but like the mirror function's kind of weird with assemblies, because I think sometimes it'll mirror it, but then you can still move it because it doesn't have a constraint. So I would personally just like add the part and then constrain it manually. Yeah, but yeah, I have this bolt that I just downloaded from McMaster. Wow, it's tiny. Okay, but yeah, nice bolt. So yeah, this is a good resource. Obviously, you can't buy Legos on McMaster, or which is kind of unfortunate. But for other stuff, you know, when you need hardware, this is a great place to go. Lots of companies use McMaster because they ship things really, really quickly, even though they're a little expensive. But for most companies, that extra money is definitely worth their time. So yeah. Are there any questions about your homework assignment or anything else we did today? Because that's basically it. So if you have places to go, feel free to leave. I guess I can hang out here for a little bit if anyone has any questions. Yeah, that's about it for today. Oh, okay. Yeah, I guess I forgot to introduce this. Um, your final project for this class, it's worth 90 points. I think you've seen this slide before, but this should hopefully make a little bit more sense to you now. So obviously, for your final, please don't make anything that we've already made in this class. Kind of self-explanatory. But then it must contain more than 5 design features. So again, each design feature is like an extrude or a revolve or something like that. So, 5 design features is not that hard to achieve. So, for the hair dryer assignment, I think we've got pretty close to that already, if not more. So just keep that in mind. The requirements for the final isn't very like, crazy. So don't be intimidated by the fact that it's called final. Because it's not that bad. Yeah, I'm just kind of introducing it to you now, or reintroducing it to you, because you can either start thinking about what you want to model, or you can start modeling now if you want. This final is due 1 week after the class, after week 5. So, after week 5 concludes, you'll have another week to finish your final, and then I'll start grading all that fun stuff. So, yeah. Does anyone have any questions about the final? Also, there's an extra credit opportunity for this week. Modeling the Amelia Earhart airplane. I'm not going to go over it like in class, but if you want extra credit, you can do it. It used to be required, but we moved it to extra credit because it requires surface modeling, which is it's kind of out of scope for everything else that we've been doing. So yeah, this option is there for you if you want extra credit to learn how to surface model. But we're primarily focused on solid modeling in this class. So yeah, this is extra credit. But yeah, other than that, that's all I have for you. Um, feel free to stick around if you have any questions. Oh, yeah. Um,